Facial recognition technology has a shockingly high error rate when identifying people with darker skin tones. A new AI-powered hiring system rejected far more female applicants than male applicants, even though both groups were equally qualified. And a recent study found that when asked certain questions, a popular chatbot gives significantly different answers based on whether the person asking the question is male or female. These examples all come from the same source. You guessed it, artificial intelligence. If AI is supposed to be objective and neutral, why does it often inherit our own human prejudices? Let's dig deeper. Hello and welcome to this channel. If you want to learn how to code or advance your machine learning skills, then this is the right place for you. Let's jump in. Today we're going to talk about AI bias, which is a term used to describe the tendency of algorithms to make unfair or prejudicial decisions. We'll break down how bias enters AI systems and what we can do to fix it. Along the way, we'll examine some of the ways that AI bias manifests itself in the real world. By understanding the nature of AI bias, we can work toward creating more equitable and fair AI systems that benefit everyone. First, let's start with a formal definition of AI bias. In essence, AI bias refers to situations where an algorithm produces significantly different results for members of different demographic groups. But there's one important thing to keep in mind: AI bias is not always intentional. It often creeps in subtly through the data that the algorithm is trained on, the design of the algorithm itself, or the context in which it's used. Let's use a simple example to illustrate the concept of AI bias. Imagine we have an AI system that is designed to determine whether someone qualifies for a loan based on their income and credit history. If the training data contains a significant number of individuals who did not qualify for loans, it is possible that the algorithm could learn from this data and end up denying loans to a disproportionate number of people from certain demographic groups, even if those groups are equally qualified. This happens because the algorithm is essentially making predictions based on patterns in the data, and if the data reflects existing societal biases, the algorithm will likely perpetuate them. But the issue doesn't stop there. There are actually three main sources of bias that can creep into AI systems. The first is data bias, which occurs when the training data is incomplete, skewed, or based on historical data that reflects existing societal biases. As we saw in the previous example, training an algorithm on data that already contains biases can result in a system that perpetuates those same biases. For instance, if the training data for a facial recognition algorithm is mostly composed of images of light-skinned individuals, it's likely to perform poorly when identifying people with darker skin tones. The second source of bias is algorithmic bias, which can arise from the design of the algorithm itself. Even if the training data is neutral, the way that the algorithm processes information can introduce bias into the system. This can happen in a number of ways, such as by relying on stereotypes or making assumptions about the world that may not be true. To continue with our previous example, imagine that a facial recognition algorithm was designed to detect smiling faces. If the algorithm only detects smiles that are wide enough, it might not accurately identify people with darker skin tones as smiling simply because they may not smile as broadly as people with lighter skin tones. This example highlights how algorithmic bias can arise from seemingly innocent design choices. Finally, the third source of bias is human bias, which can creep in when developers make decisions about how to design, deploy, and evaluate an algorithm. Even if an algorithm is technically accurate, the decisions made by developers can introduce bias into the system. This can happen consciously or unconsciously, such as when developers choose which features to focus on or how to handle missing data. To illustrate this concept, consider a hiring algorithm that's designed to review resumes and identify candidates that meet certain criteria. If the algorithm was developed by a team of male engineers who primarily hire male employees, it might inadvertently favor male candidates over female candidates, even if both groups are equally qualified. This can happen because the engineers might unconsciously decide to prioritize traits that are more common in men, such as assertiveness, or they might inadvertently exclude traditionally feminine traits, such as nurturing behavior, which are also valuable in the workplace. It is important to note that these three sources of bias are not mutually exclusive and often interact with each other to create complex biases in AI systems. Now that we've covered the basics of AI bias, let's look at some real-world examples. In recent years, there have been numerous studies that have highlighted the racial bias in facial recognition algorithms. For instance, a study published in 2019 found that a popular open-source facial recognition library had much higher error rates for darker skin tones than for lighter skin tones. Specifically, the algorithm was 10 times more likely to incorrectly identify a black person as a different person. This bias can have serious consequences, such as when law enforcement uses facial recognition technology to identify suspects. In these situations, a false match could lead to the wrongful arrest of an innocent person. Another area where AI bias has been widely documented is in the field of hiring. A study published in 2018 found that an algorithm used by a major tech company to filter resumes favored male candidates over female candidates. The algorithm was trained on historical hiring data, which likely contained gender biases. As a result, the algorithm was less likely to call female candidates for interviews, even if they were equally qualified. This type of bias can perpetuate gender inequality in the tech industry and make it harder for qualified female candidates to land jobs. Finally, let's consider the example of healthcare AI. A study published in 2019 found that an algorithm used to diagnose certain conditions was less accurate when applied to patients with darker skin tones. This bias can have life-threatening consequences since patients may not receive timely or appropriate treatment. As we've seen, AI bias can manifest itself in many different ways and can have serious consequences. So why should we care about addressing this issue? First and foremost, it's simply the right thing to do. Creating fair and equitable AI systems is a matter of social responsibility. We don't want to perpetuate harmful stereotypes or discriminate against individuals or groups. Secondly, failing to address AI bias can lead to significant inequality and injustice. When AI systems make decisions that are based on biased data or algorithms, it can reinforce and even amplify existing societal biases, which can lead to unfair or discriminatory outcomes. For example, as we discussed earlier, AI-powered hiring algorithms can make it harder for women or minorities to get hired, which can perpetuate gender and racial inequality. Similarly, biased healthcare AI systems can deny treatment or provide inadequate treatment to certain groups of patients, which can have life-threatening consequences. Finally, failing to address AI bias can erode trust in AI technology. When people see that AI systems are making unfair or biased decisions, they may lose faith in the technology and be less likely to use it, which can limit the potential benefits of AI. However, despite these challenges, there is reason to be optimistic. In recent years, there has been growing recognition of the importance of addressing AI bias. As a result, there has been a surge in research and development of tools, techniques, and best practices for mitigating bias in AI systems. One promising approach is the use of diverse and representative datasets. By training AI algorithms on data that reflects the diversity of the real world, we can help ensure that the algorithms do not perpetuate harmful stereotypes or discriminate against certain groups. Another approach is the use of bias audits and transparency reports. By regularly auditing AI systems for bias and making the results public, we can hold developers accountable and encourage them to build more equitable systems. Finally, regulation and ethical AI design can also play a role in mitigating bias. By setting clear guidelines and standards for AI developers, regulators can help ensure that bias is not being perpetuated and that AI systems are being used in a responsible and ethical manner. Ultimately, addressing AI bias will require a multi-pronged approach that involves researchers, developers, policymakers, and all of us as users of AI technology. So what can we do as individuals to promote fair and equitable AI? One important step is to develop a deeper understanding of AI bias and its potential impact. By learning about the different sources of bias and how they can manifest themselves in AI systems, we can be better equipped to identify and challenge biased AI when we see it. We can also support organizations that are working to develop more ethical and responsible AI systems. By donating to or volunteering with organizations that are focused on mitigating AI bias, we can help advance the development of fair and equitable AI. Finally, we can demand more transparency from AI developers. By calling on companies and organizations to be more open about their AI systems and their potential biases, we can help create a culture of responsibility and accountability. Let's end today's discussion with a call to action. Do you think AI can ever be truly unbiased, or will it always reflect human flaws? Share your thoughts below. And that's it for today. Thanks for watching. Don't forget to like, comment, and share. If you enjoyed the video, hit the subscribe button to stay updated with our latest videos. We'll see you next time.